Hello, my dear student. I'm Mr. Kitwala from Educare TZ. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on our topic of rotation of a rigid body. For our subtopic of torque of a rotating rigid body. So, welcome again for our discussion here. But before we proceed with our discussion, we are supposed to remember where we ended on the last session. On the last session, my dear student, we tried to see some examples related with the mechanical energy. We tried to see how can we demonstrate the formula of the velocity when the body rotating on an inclined plane. And we say that the velocity of the rigid body rotating on an inclined plane must be equals to radical of 2g L sin theta, then we divide it by 1 plus 1 of mr square. Or sometime when we have been given in terms of the height, we should express v equals to radical of v equals to radical of 2gh, then we divide it by 1 plus 1 of mr square. But sometimes 1 over mr square can be represented in terms of c. Kwa tutasubstitute pale ni sawa na c, reciprocal of mr square. This is what we tried to see on the last session. Finally, we tried to see some examples which say that imagine we have the solid sphere and also the solid disk and finally the solid cylinder. They are rolling together. Which amount of them will reach at the bottom first than the other? And we say that always the sphere starting at reach at the bottom, followed by that the disk and the last one become that of the cylinder, ndio inakuwa ni ya mwisho kufika chini. And today, my dear student, let us see example here related with what we tried to see on the last lectures. So our example number 4.14 here say that consider a solid cylinder of mass m and radius r, which is made to roll down a plane without striping. That we are supposed to consider the solid cylinder. We have the solid cylinder, and that is solid cylinder, my dear student, having the mass m and also the radius r, which is made to roll down a plane without striping. It's trying to rotate on an inclined plane without being striping. Now, how can we find the speed of its center of mass at the moment of inertia, after the moment when the cylinder reaches at the bottom of an inclined plane on the figure number this one. Find the speed of its center. Now we have the cylinder, and that is so the cylinder containing the mass m and also the radius r. Now this it is tried to be placed at the top of the inclined plane. Then it undergo rotation. If they undergo rotation toward downwards. Now which speed it could consume to reach at the bottom? This is what we have been asked on our question here. Now imagine we have this inclined plane, the figure that we have been told on our example here. So our figure number 26 for our fourth topic here, explain a solid cylinder rolling down the plane without striping. In a row without being striping. So we have the inclined plane. This inclined plane having the height h. Tunaona ina height h, my dear student, and also having the horizontal distance. Finally, it have the length. This is length line on the inclined plane, And finally, my dear student, having the sphere. This is the cylinder, and this cylinder initially was at the point A. When it was being displaced, kwa alipoiachia pale kwenye point A, iliweza kuslide kuelekea chini. Ndio tunaiona hapa imefika chini at the center, lakini inclined plane yetu ina angle theta, ina angle ambayo ni sawa na theta, as we try to demonstrate. So how can we find the velocity through the center? The velocity wetu atakuwa ni ngapi through the center? This is what we have been asked into our equation here. So let us observe our solution, my dear students. And our solution, as we see that using the moment of inertia of a solid cylinder, ambao ni sawasawa na half mr square. Now about an axis through its center, W must be equal to V divided by R. Now in equation number 87, we have demonstrated or derived our equation number 87 for our fourth topic. Now we could consider the conservation of energy of the rolling object at the bottom can be expressed by this one. Our equation number 87 for our first topic was explained about my dear student, about the conservation of energy of a rolling object at the bottom, which can be expressed at this one. As we observe the nature which the equation was being represented, and we have tried to say that when the rigged body, or when the cylinder is at the top, it is purely the mechanical energy, it is purely a potential energy. And also when it reach at the bottom, kama tunavyoiona sa kwamba hii cylinder yetu ilipokuwa hapa juu, ili mechanical energy ilikuwa ni pure kabisa, ni potential energy, lakini ilipofika hapa chini, yule mechanical energy akawa pure kabisa, ni kinetic energy, as we try to see, my dear students. So using this formula here, kama tunavyo jaribu kuobserve kwamba mgh must be equals to half mw square, then we divide half I w square, then we add by half mv square. But we know that this moment of inertia here must be given for the cylinder is equal to 1 divided by 2 mr square. So instead of writing this I, we should substitute mr square. And if we substitute mr square divided by 2, the remaining one must be equal to r squared. We should obtain the product of r square times the angular velocity square. But we know that r square times the angular velocity square must be equal to v square. So instead of writing r square times the w square, we should write this v square, as we try to see. But the half that we have tried to substitute for the moment of inertia here should be added, should be multiplied by a half that it is present here, ile half inayopatikana hapa kama tunavyo observe. So what we are supposed to do after simplifying this one? After simplifying, my dear student, we could get that mgh must be equals, we are supposed to find the LCM. If we find the LCM, the mgh must be equal to 3 divided by 4, then we multiply it by mv square. Kwa formula yetu itakuwa ni hivyo. Yule mgh atakuwa ni sawasawa na 3 divided by 4, then we multiply it by mv square. Sasa hii imetokaje? Ilichotoka hapa, tulichofanya tumetafuta tu kigawe kidogo cha shirika kama tulivyosoma tulipokuwa tuko shule ya msingi. Kigawe cha shirika kidogo kitakuwa ni 4, baada hapo tuka cross multiplication, tukaya fact out yale ma values ambayo yalikuwa ni constant. Mwisho wa siku tukapata formula yetu ya 3 divided by 4 mv square. But the m is common, as we try to see that here we have m at the right side, and also at the left side we have m. Now we could say that v, if we omit that m, the v square must be equals to to 4 divided by 3 GH. Kwa hiyo V square atakuwa ni 4 divided by 3 GH. But we want the V. We are not asked to find the V square. We have been asked to find the V. How can we get the V from the V square? We are supposed to introduce the radical throughout. If we introduce the radical throughout, here the radical should be cancelled with the power, ambapo power yetu ilikuwa ni 2. Na huku atahamia upande wa pili. Sasa tutapata kumbe V wetu atakuwa ni sawasawa na radical ya 4 divided by 3 times the GH.